dive into ML without understanding the technicalities of it. So in order to reduce that, we hope that students can get the insights first and then approach any concept in machine learning. We also provide support to student research and projects. If anyone has any ideas or they want to work on something, they are always free to approach SMLRA for it. Our goal is to inculcate AI research in the people. And finally, we provide a community for direct interactions with the researchers. We have conducted events in the past where we have called experts from institutes like IIT Bombay, then various technological companies who have given talks on various AI concepts. So, uh, yeah. So to begin the session first, we will have a Pi and AI greeting by none other than Andrew Ng.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey, Kian. So do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
And that's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, data sets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
So before we start today's session, I would like to speak something about a very special speaker today, Mr. Shaun D'Souza. So he currently works in Accenture and has worked in the past with many companies like Intel, Wipro, etc. He has completed his BS from Cornell University with a double major in computer science, electrical engineering in 2003, and he did his MSc in electrical engineering from the University of Michigan in 2005. He has over 12 years of experience in multitude of fields like AI/ML, software engineering, R&D, and business. He has worked on the software business researching side and has worked on various concepts like compilers, algorithms, and systems. He has published around 8 papers and he has also been granted a patent. He has currently filed for multiple other patents. So I would request Mr. Shaun D'Souza to kindly take the stage.
Thanks, Arghyadeep. Am I audible? Go ahead and share my screen. Is everybody able to see my screen? Okay. Arghyadeep, should I go with the MS part first, or should I do the past and future of AI first? Because I guess
I think we can go ahead with the past and future, because when we do with the MS, we will immediately start with the doubt session after that. So it will be fresh with the people.
yes, okay. So hi everybody, my name is Shaun D'Souza, and I'll be talking about the past and future of AI in this Pi and AI talk today. You can follow me on this URL at the bottom of the slide. So in today's talk, we'll be looking at machine learning, which is a subset of artificial intelligence. And in a broader set of umbrella terms, artificial intelligence is a subset in computer science. And within machine learning, we have supervised learning, which includes classification and regression. And we have unsupervised learning, which have text clustering. And then I'll also touch upon NLP, which is natural language processing. And I'll keep this open also. So if anybody has questions at any point in time, then just feel free to speak up, and I can answer the question, because I know we are in online with the COVID pandemic, but feel free to ask me at any time any questions.
Regarding the questions, if any one of you has any questions regarding the session, I will be providing a link in the chat. You can click on it and post your questions on it, and we will take it afterwards one by one. So I'll be posting the link now.
Okay. So on the business context side, the future has intelligent machines and the Turing test. This is something that was postulated by Alan Turing. So I'm just to look at some of the highlights that we have. And then we have the next iteration of the internet, which I call the Web N. And we potentially have tens of billions of users that are going to be online tomorrow, and this could be they could be connected on any type of device. Along with this, we have the law of accelerating returns, and these present an economic value in excess of 100 trillion market value. And what folks like Andrew Ng refer to this is the fourth industrial revolution. This artificial intelligence is predicted to be the fourth industrial revolution. And if you look back over the last century, we had the first industrial revolution, I think, was with the steam and the railroads. And we've had multiple revolutions after that. I think green revolution for agriculture in India. So artificial intelligence is the fourth industrial revolution. Some additional benefits that we have today are open source intellectual property, revenue for a lot of these corporations, products and services. Again, there are licensing models, research and development, open innovation, and open source. And the
Sir,
strategy.
sorry to disturb, but your voice is breaking a bit.
Okay, I don't know if my microphone is connected or if I'm using the. Can you still hear me now? Or is it better? Or?
Yeah, it is better now.
Okay, I think my headphones are not connecting, and I cannot call in using the phone also. So I'm just going to.
I think the internal microphone should work.
Yes.
Yeah.
And so we have a strategy pairing in business to business on really a case by case basis. We are looking at how do we scale a value system for AI. And then we have prices and margins, and we have competition that is growing in a global world. We have converging global supply and demand and evolving business models. So this is a slide that I borrowed from IBM because they were the leaders in the area. So this talks about how cognitive systems work. Essentially what a cognitive system can do is it can understand whether that is imagery, language, or any unstructured data. It can do that similar to what a human does. It can reason, that it includes extracting hypotheses and inferring and extracting ideas. Then it can learn like a human, and it can interact in a natural way, whether that is talking or hearing. So these are essentially the feature sets that we are trying to build into our systems and products today. So this is what constitutes IBM's Watson brand. What is machine learning? This is a very good contrast. I think that you'll see this is a lot of the early, what you see on the left is some of the early paradigms in which applications were developed. So developers would have to sit and explicitly write a set of code, whether that is conditional if-else statements or any other logic. It would have to be programmed by a developer explicitly. And on the right, we have the new paradigm where we now have AI and machine learning. And there are a lot of algorithms, whether they are your machine learning algorithms or deep learning algorithms. And the box that you see shows is depicting the algorithms. And it's not really a black box, but it's shown as a black box. We know how to develop these algorithms today. And essentially, we have a new paradigm where the application is fluid in the data that is ingested. So we provide an input to the algorithm, which is the data set, and that gives us a trained model for the data. And so the user doesn't have to go and explicitly write a set of rules. That's one of the use cases. This is some of the applications of natural language processing. These include machine translation, knowledge representation, information retrieval, text categorization, extracting data from text, spoken languages, and spelling and grammar checkers. So a lot of these, yeah, I'll emphasize that a lot of these are deep subjects in themselves. So textbooks have been written on each of these areas, and I don't want to take away from the exercise, and so there is a lot of literature available online also, and I'll speak about it in the second presentation. Yeah. AI problems or machine learning problems contain your supervised and unsupervised learning. You have supervised and unsupervised learning, and then you have discrete and continuous problems. Discrete problems in supervised learning are called classification problems, and in unsupervised learning they're called clustering. And then continuous problems in supervised learning are called regression, and in unsupervised learning they are dimensionality reduction. So this is a slide on what is supervised learning. Supervised learning contains and yeah, I guess some of the information here is available in the AI textbook from Peter Norvig and Stuart Russell. And so I don't know if the Mumbai University curriculum has changed, but from what I understand, it wasn't included. Some of this portion wasn't part of the curriculum, but I'm anyways going to talk about these aspects of machine learning. So in supervised learning, we have a set of training examples, and so here we have user notation S is a set which contains your XY supervised input-output pairs, and the classification set is provided where Y belongs to a set of outputs from 1 to M. And what we're trying to do is discover in continuous learning is discover a regression y equals fx, and in a discrete supervised learning, we'll be trying to discover the hypothesis function, which approximates f of x. And again, x and y can be any values in this case. And we'll look at a few examples in the subsequent slides, so you have some idea. So this is a slide on regression. This was the data set is from the WHO data set. I think it might be available on Kaggle or on the WHO website, and it had a set of metrics for the population. And so we see the data set over here. There are two distinct trends for health expenditure per person as a function of the gross national income per person. And what you see in the second plot is a linear regression plot. This has been done in R. So using the LM function, so you simply have to import the data set and use the linear regression function, and you see a distinct line over here, which is your regression plot. Similarly, this is the same data set is being approximated with the polynomial regression function, and this is a second order polynomial over here, which uses the R code LM library with poly x comma 2. And on the fourth plot is a k nearest neighbors regression. And this is again using the 3 nearest neighbors to create a regression So in most of these examples, we're trying to approximate a true function with the hypothesis function, and there is subsequently some error in making that approximation. So the linear function will give you more error as opposed to any of the other functions. So yeah, I'll just go back again. Yeah. So all of these, the goal over here is to reduce the error in the loss function. Now I'll talk about gradient descent, which is a technique that is used in scientific computation. So I think some of you might have already learned it in your second year cognates or electives. I'm not sure what they are called, but yeah, you should study this in a university, and it's a very simple linear algebra, and we are just describing the linear approximation for the hypothesis. This is your linear regression, where h of x is the weighted, the dot product of w1 with vector x plus the bias weight. And in the second line, we define the loss function as the mean squared loss function, which is a summation of the difference in the actual value y minus the predicted value, and we square this, get an absolute value. This is the stochastic or batch gradient descent that you see. This is simply a iterative update of the weights, which is done using the loss differential of the loss function and alpha, which is a learning rate. And so this is your calculus, high school calculus, which will give you the loss function differentiated for a square value is 2 times the value times the differential of the function. And this is just expanded then for a weight W0 and W1, which gives us these two values over here. So these are the weighted updates that happen in stochastic gradient descent to update the parameters for your regression that you are trying to predict. And I have an example that I'll show in the subsequent slide. So this is used to very successful manner in the deep learning neural networks that you see, and I'll talk about it in the subsequent slide. So this is something that all of you, I think, this is if you're in multiple disciplines, AI today is interdisciplinary, so everybody will be using it in some form or the other. This is what the early perceptrons used to look like. These were very simple with step activation functions. They simply did a summation of the dot product of the inputs with the weights. This is a single layer perceptron on the top that you see. And it has a simple step activation with the y equals 1 and y equals 0 if the dot product is greater than 0, otherwise it's 0. And this is guaranteed to give you a linear hyperplane if the data points are separable. And I have a demo for this. So this is just a Python notebook so I'm assuming everybody can see my screen. So this just shows 6 points in a 2D space, and what this algorithm, the Perceptron algorithm, is trying to do is find a linear plane of separation between these points. So you'll see when this it runs, it will find a separating plane. So in this case, this is the plane which was found. This is running it again, but you can see that it finally discovers the plane of separation. And this is done in a batch iteration process. This can be your stochastic gradient descent or your batch gradient descent. And the shortcoming with this technique was that it didn't support back propagation because the activation function was not a continuous function, and so we couldn't have deeper layers of we couldn't use deeper layer networks. And the scientists took about a decade to discover back propagation, and this was the AI winter that they term it as. Subsequent to the AI winter, we discovered back propagation. And again, these algorithms have been around for around 30 to 40 years now. So we can, while it's becoming mainstream today, a lot of these have been around for more than 30 to 40 years. And these are some of the activation functions. The threshold function is the perceptron, the sigmoid activation, softmax, and hyperbolic tan. These are continuous activation functions, which are illustrated here on the right side. So you can have very deep layers of these networks, and these solve very sophisticated tasks similar to a human, like looking at images and text. So this is what a deep learning network is like. Just see if there were any more. And so this slide talks about classification. This is a data set, iris data set, which is used in a lot of introductory use cases. This is from Kaggle, and it looks at 3 species of the iris flower. And we try to categorize these using the length and width of the sepal and the petal. So these are just 3 species of the iris flower. And on the right, I have some code that uses the Python scikit-learn library. And it is able to split the data set into a training set and a test set. Again, these are terms that you will learn when you look at an AI textbook. So you typically have a training set and a validation test set. The training set is used to train your AI algorithm. So this is, we run the fit function, and this is using the SVM library in sklearn. This is a support vector machine. And then we use the predict function to determine the Y outputs, and we are able to do this with more than 95% accuracy using the SVM library for this iris data set. This is an example for or a decision tree and naive Bayes. These are again 2 classification algorithms. So this is something that I was going to show you in the next. So these are some of the textbooks that are available for AI. So if you, yeah, these are available on any retailer online today. And I think as time permits, this is something that you can look at. So this is an implementation of a decision tree, which is a supervised learning classifier. And this is the naive Bayes, which is one of the more elementary classifiers available. And you can see that it's showing the decision tree output for the iris data set over here. So it makes a decision depending on the petal width and the sepal width. And similarly for naive Bayes, this is the most informative features that you can view. This is done using the NLTK library. This is part of Stanford. we'll just look at the naive Bayes classification. So this just has some math over here. It's just a probabilistic math that is used for the naive Bayes estimator. It uses a bag of words along with the count values, which you see over here. That's the probability of the word given the class, and you count the number of words and you divide it by the total number of count words. And so here, these are your training set and test set where you have Chinese, Beijing, Chinese is Chinese, whereas Tokyo, Japan, Chinese is Japanese. And you're trying to figure out how to predict what is Chinese, 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 Tokyo, Japan. And so given these conditional probabilities, naive Bayes predicts that the fifth the conditional probability that is Chinese given the fifth line is 0.0003, and whether that is Japanese is 0.0001. So this would be predicted as Chinese. Clustering is a technique in unsupervised learning, and there are different clustering algorithms. K-means clustering is one of the most used clustering algorithms. This unsupervised learning inputs consist of features x1 through xn, and what we're looking to do is minimize the sum of squares distance to the cluster centers. So here we see this is a K-means clustering for the iris data set implemented in R. And we are importing the CSV file, and we then determine 4 clusters, I think, for the data set. So this is the clusters by the sepal and petal lengths and widths. You can see the data points are drawn in circles, and these are the crosses correspond to the clusters for the K-means clustering algorithm. And I'll talk about how this is done in the subsequent slides. This is some work that we had looked at with the OpenNLP library. This is an open source library from the Apache project, and it has a lot of useful features for text applications. These include tokenization, part of speech tagging, chunking, parsing, and named entity recognition. And I provided the commands for each of these use cases. Named entity recognition is used in applications in the semantic web, where you're looking at discovering semantic information in unstructured text. So, for example, in this sentence, Pierre Winkin, 61 years old, will join the board as a non-executive director. It identifies Pierre Winkin as a person. You can see the start, person, and end tokens. Again, I won't talk about the details here, but this is some of the training information over here. This is the feature generator in OpenNLP, which is used for entity detection. This is part of speech tagging, where we assign a part of speech tag. This is just a grammatical noun verb part of speech tag to a word in a sentence. So, for example, here Pierre is noun, Winkin is noun, 61 is cardinal, years is a noun, old is an adjective. These are just part of speech tags assigned to words in the sentence. Chunking is another application in text processing. It is also called shallow parsing, where we are assigning the text into syntactically correlated groups of words. So these could be noun groups or verb groups. And this is the command in OpenNLP. And you can see here we have a noun chunk, the name of the person, 61 years is another noun chunk, will join is a verb chunk. So both of these are used in annotating unstructured text, and you can build additional rules on top of these to make meaning or to extract information. This is a slide on training the chunker model. This is the format of the data set. It uses a BIO formatted data set. This is the parser model. This is parsing. It passes unstructured text into a tree like a NRE tree. So this is what unstructured text passed would look like. You see, you have your noun assigned to a parent noun, which constitute a noun phrase in the tree. So this is what a tree data set looks like. And this is done by the OpenNLP parser. We'll now look at text clustering. So in text clustering, we're looking to partition unlabeled examples into disjoint subset of clusters. And we discover new categories in an unsupervised manner. So there are no category labels provided. For example, this is your simple data set. And these are the clusters that it determines. So these are different levels of text representation. You have your characters, words, phrases, you have language models, and you have ontologies. So you have usually lexical representations, syntactic representations, and semantic representations. This is a simple bag of words document representation. It demonstrates how we discover the bag of words representation. So this is a sentence paragraph over here, and all this does is it discovers the word counts corresponding to the words in the paragraph over here. What you see on the right is a bag of words representation. So you see the word journal appearing 3 times. This is word weighting. This is uses the TF IDF, which is the term frequency inverse document frequency. This is a normalized word weighting that is available. And document similarity is measured using a cosine similarity metric. So this is how we compute the cosine similarity. This is a dot product that is used to compute similarity between 2 vector of weights. These are some of the techniques for unsupervised document clustering. We have k-means clustering, and we have expectation maximization. These are some of the alternate approaches that are available. I'll talk about what is k-means. So we are given a set of documents which are represented by their TF IDF vectors and a distance measure cosine. We are looking to assign them to 1 out of k groups. So we initialize the centroids to a random document. And while we are not converging, each document is assigned to the nearest group represented by its centroid. And for each group, we calculate a new centroid given all the documents that have been assigned. And this is just the big O notation. This is the order of complexity for k-means. Again, finding a global optimum in k-means is NP hard. NP is non-deterministic polynomial time. And the objective of k-means is to minimize the total sum of squares distance of every point to its corresponding cluster centroid. And k-means is guaranteed to converge to a local optimum. The results that you see will depend on the seed that you use. So there are different heuristics for using a seed initialization. This usually comes with the library, whether it's an NLTK or scikit-learn library. This is some of the more recent work that has been done in the Word2Vec from Mikolov and his colleague Thomas Mikolov from Czechoslovakia, and this is more recent work that had come out of Google, and they use word vectors to look at words in unstructured text. These use the continuous back of words and skipgram models, and these are available today in a lot of the deep learning libraries. So these are some of the reference libraries that I talked about. There's OpenNLP, which is from the Apache project. You have a scikit-learn, which is another open source library. NLTK is from Stanford, and R is a recent library that is, I mean, it's been around for some time. R is another available language that is. So I guess I'll take questions at the end of or during this session. Yeah, these are just some additional links that I've included. These are some courses that are available in Stanford. So I think if we go back 10 years, then MIT used to have open courseware at the time. I remember when I was in school, and a lot of universities used to publish the course content on their website. And today you have these online MOOCs, which are massive online courses, and like Coursera and ETX. But these are some of the early websites where you could also look at some literature. And then you have knowledge systems with vast repositories of structured and unstructured data, and you have repositories like Kaggle and the CONLM dataset. So that's all I had for the first part of the presentation. Did anybody have any questions or?
Yeah, there are quite a few questions. I'll read them out to you one by one.
Yes.
Yeah. So where is it? Yeah, so the first question is, I know that maths is necessary for ML and DL to gain a great insight and understanding of models and optimization algorithms. But the more you dig deeper, there is more and more maths. So how much maths should I know?
So I think, yeah, there are multiple aspects. So obviously, any of these research areas, you have to have a zeal or some kind of enthusiasm. You have to have some affinity for the subject. So yeah, you have to be good in math and your algebra. You have to know your algebra and your calculus. And then yeah, I think it's really you Yeah, I think it goes both ways. You can it can keep, you'll have to learn a lot, and you can keep learning for a long time. So I think today the concept is that it's learning is lifelong. So I can't really say that you stop learning in high school or after your PhD, or you always you have to you will always have to learn something.
Right. The next question is for masters, is it good to take CS and take specialization courses for AIML, or do master in AIML directly?
So I don't think there's any masters in AIML. I think the you receive a master's in computer science always. So yeah, you have to. It's then depending, and I'll talk about it in the second presentation. So depending on the school, then you would have a department of for AI where you would specialize in AI, but you would still have a master's in computer science.
But I think they are introducing like MSAI and things now, right? Like various universities are providing specialization MS degrees.
Yes, so it again depends from university to university. So this is something that I'm going to talk about in the next talk. Some universities have, like Michigan has a joint PhD program, and you enroll in the PhD program and you complete your masters on the way to the PhD. Whereas some schools you apply for a master's entry itself. And if you look at schools like Cornell, they also, in addition to the PhD, they have a 1 year Masters of Engineering where you can complete your masters in 1 year. So it really in the US education system, unlike India, there is no board like a Mumbai University board or a Delhi University board. It is every university has a board as a syllabus that they prescribe. So you cannot generalize these. You have to go as per the university which you are applying to. So it really there's no benefit. I think one versus the other. I think you will learn the equal amount of your learnings will be commensurate in both of the areas. I think a computer science specialization would expose you to other aspects of AI/ML. So yeah, I really can't comment on which is better, which would be better. The conventional thought is, yeah, you get a computer science, a foundation in computer science, and then you specialize in AI/ML. But today you can go the other way also. So I'm really not saying one is better than the other. So whichever program you get admitted into, I think that you should take up that opportunity.
Right. So another question which has been asked is, what was the continuous prediction in unsupervised learning?
So continuous prediction is just you are not bucketizing your data. So you have discrete and continuous use cases. So continuous representation just looks at some aspects like I think dimensionality reduction. So that's just one of the aspects. So the idea there is just that you don't have discretized values like you would have in a clustering algorithm. So it's related to like matrix algebra, something that you would learn in matrix in your matrices.
And then next is, what should be the course of action for an absolute beginner?
So I think this is something that I'll talk about. I was going to talk about in the next presentation. Is so as far as I see it, I think there's if you're a student or if you're even an person working, I think there's no substitute for education. So I think everybody should invest in an education. If you're an absolute beginner, there is a lot of content. So today that education is going online, and there is content available online. So again, there's it's apples and oranges. You can't really compare them. which is better. So I think it's more you have to go with the flow, the opportunities. You have to choose the best of the opportunities that is available today. So just you would have to use Google or uh, I don't know what forums your the present generation go to, and just yeah, look at what is the latest and greatest in what is available online. But there's just so much happening, so I can't really point you in any one direction because then it's something that it has to come from the individual. It's not.
Right. And there are many courses which are available at the click of a button right now. So it's all upon how one explores the internet.
Yes.
Yeah. So I'm seeing some MS questions as well. So I think after the session we will address these questions. So it will become some of these doubts may get cleared in the session as well. So I'll be holding these questions for now, and we can start with the second part of the session.
Okay. Yes. Uh, is my or do I have to share it again?
Yeah, the presentation is visible.
Okay. Yeah, so I'll talk about MS in AI. So this is a short presentation I had. So I guess my intention over here is to talk about my experience in the subject, and so I would like more questions from the audience. That said, this is a broad overview of what is computer science today. And today, computer science has artificial intelligence, machine learning, you have your database, you have graphics, then you have your systems and networking, and you have programming languages and algorithms theory. AI is one aspect of computer science, and so there are a lot of other areas also available. In India, there are a lot of jobs that are in AI today, and what you find as a data scientist. So, but really, there are a lot of fields in computer science, and uh, yeah, so you'll find equal value in any of these areas, but I would recommend you pursue something artificial intelligence and machine learning related. And it would be important that you have working knowledge of the other aspects of computer science also, because you really don't want to be uh, like a horse with blinkers on. So you want to have a view of the field itself. So what are the resources you can pursue as a student? Uh, there are standardized tests. From what I understand, people are pursuing education abroad these days. It used to be when I was in school, we used to hear of the brain drain maybe 10 to 20 years back, and today it's the reverse brain drain because folks are coming back. So I really don't want to sell this as an immigration thing. It's if you're going for an education, then there is a set of standardized tests. If you're going for an undergraduate education, there's an SAT 1 and a SAT 2 subject test, and the TOEFL test. And if you're going for graduate school, then there's the GRE uh, uh, test for either a master's or a PhD program. And Cornell, I know, has a 1-year MEng program, a Masters of Engineering. So that's for anybody who wants to graduate in a year's time with a master's degree. So again, there is no standardized syllabus in any of the foreign countries, unlike India, which has a more standardized format for education. But the degrees themselves are the university's syllabus, something that comes out of the university. And in terms of funding for the education, you have scholarships. Again, these vary from country to country. The UK, for example, I think has a public education system. So you don't pay till you are in, I don't think you pay for education in the United Kingdom. Whereas in countries like the US, it's a private affair. So you have to pay out-of-pocket expenses for your education. So I don't know if that is changing now also, but there are scholarships that will assist the student in recuperating those expenses. Those are provided by the university and external resources also. And I know for grad school, there are programs like the teaching assistant and the research assistant. These are in a teaching assistant program, you work with the professor for taking a class over a semester. So you work with the professor and the student. You assist the professor for teaching the graduate or undergraduate class. And in a research assistantship, you are that is something that comes as a grant to the university for working on a specific research project. So that usually goes towards your graduate research or your thesis. So those are some of the options available, and they provide a standardized stipend that covers your expenditure on campus and your tuition expenses. So, but again, I am not I wouldn't be the person to have all the insight on all aspects of, I think, studying abroad. This is just my perspective. I completed my undergraduate from Cornell, and then I went to graduate school at the University of Michigan, Ann Arbor. So this is what my view was at that time. I remember going to Yusufi a lot, which is in Churchgate. The Yusufi library is there. I don't know if it has moved now. There is a lot of I think I would recommend that you connect with an education consultant. I think the Yusufi library, which is the US India Education Foundation, that is a good place to start if you are interested. And then I think these are two other resources that I found online. One is Madhavi Desai. I think she's an education consultant, and this is a batchmate of mine from University of Michigan, Ann Arbor, Dhaval Mehta's company. He has a company, TNI Career Counseling, and they do education consulting and counseling for students. So I think you could browse the web, but I think it would be more useful to seek professional guidance from a consultant. And these are some of the resources that are available online. So this is something that you should use. And I seen today there are online formats also for each of these degrees. Again, I really am not the person to make. I couldn't comment on which would be better, one versus the other. It's really on a individual circumstance. You have to make an assessment on which you have the propensity to pursue, whether you want to go abroad in person to study, or whether you want to complete the degree online. I think there's no substitute for the traditional education model, but things are changing given the the economics and the globalized world that we have today. So a lot of the education is moving online, and it's I think the experience for the student could be a little different, but it really it depends on an individual level, the assessment itself. And again, I want to point out that these are more like guidelines. So I'm not, you can, this is just something that you can think about, and you can always approach somebody with more knowledge about each of these areas. These are some of the textbooks that are available online. You can purchase a copy. I think the average book costs less than 500 rupees today. So it's, I think it's a investment. It's money well spent investing in a textbook, and you take your time to read any of these textbooks if you're interested in AI and machine learning. The textbook at the bottom was our undergraduate instructors from Cornell, Professor Kleinberg and John Kleinberg, Eva Tardos. That was our algorithms elective at Cornell. So similar to other electives that we had. This is a good book that provides an introduction to algorithms. Although today a lot of the learning is AI and ML based, so I would recommend. I'm just pointing out that this was a school instructor of ours that we knew in person. But these I would go top down in this list. This is the AI book from Norvig and Russell. It's available online. There's a machine learning book from Tom Mitchell, which is also available online. This is the deep learning and reinforcement learning textbooks that are there online. I would recommend you buy a copy of a book and give it a read. And you can always do this when you're in grad school also. So there's no hurry to get there, but this is just as time permits. So that's all I had for the second part of the presentation.
All right, thank you for that. And I think we can take the doubts finally that the people were having. Uh, yeah, so the first question is how do you think that the job scenario right now will be in terms of computer vision or any other AI ML job, with the recession creating a dent in the startup ecosystem?
So we are at a very transient, what they call an inflection point in the world. And so I don't want to say that this is something that happened yesterday with COVID. This inflection point has been around for a decade or more. I think there are multiple factors over here. There is a growing population and the economics of sustaining that population, and that includes jobs. There are multiple issues that have to be addressed at various aspects. So I think if all of you are in AI and ML, I think that's, as far as jobs go, that is a good place to be. There are a lot of jobs available in whichever format, whether it is online or any other format. There are a lot of jobs available. Beyond that, the market goes through cycles. We cannot we cannot uh, I guess we can forecast these cycles, but there's always an you are always at an point where you are an early entry into the market. So I think you should always think optimistically. There's always an upside. You are always think of it as an opportunity to buy into the job market at whatever stage you are in your career, whether you're in school or in a job. And it's a transient uh, place. So a lot happens in a single day. And
Right. So the next question is, I am more of interested in robotics and stuff, and I also heard about robotics and AI MS course. So there are some prerequisites to be known. How beneficial will it be to learn deep learning for such an approach?
yes, a lot of the work does use deep learning. So I think that is a skill that everybody will have, just like writing code, whether it was developing the Windows operating system, or today deep learning is the equivalent skill set. So everybody will be writing code for a deep learning network, and it has use cases industry wide. So you will, whether you're a doctor or a computer scientist or any other profession, you will be using some form of deep learning.
So the next question is, what are the general duties of an individual as a data scientist? Which ideas and concepts are more important?
Uh, yeah, so I guess I was going on the upside, going from computer science to AI. But within AI itself, there are a number of subfields in AI, whether you're looking at text, whether you're looking at images. Those are two different subsets. Then in deep learning, you have unsupervised in machine learning, you have unsupervised and supervised learning. You have deep learning. There's a lot happening, really. I think that would take another talk to look at each of those aspects. Uh, I think that I'm not sure if it is part of Mumbai University curriculum also. So I don't encourage. I mean, I think as it is, the students have a significant uh, portion of curriculum on their plate. So I mean, as time permits, you can always explore online. You'll find you can look at Stanford's graduate program, or look at Cornell's or Michigan's graduate program. My professor of AI at Michigan was Satinder Babeja. So there's a lot of all the literature and the work is published online. So you can always look at any of these websites. A lot of the data scientist work is just you take your data, you clean the data, and then you send it in your deep learning or in your ML algorithm, and you look at the output. So and the data today with the internet, you have petabytes of data. So there's really, you can look at text, images, you can look at anything and everything that is available online. And so the idea with AI is the AI is trying to mimic a human. So we don't so you don't feel like there's a machine on the other side. It's just it it'll walk, it'll talk, and act like a human.
Right. So, like how, like in India, not many have the distinct idea of like what is the difference between a data scientist, a machine learning engineer, and for example, say a big data analyst or something. So these are like all similar sounding to everyone. So, like, can you draw a distinction between these three roles?
Which were the first two? You said data scientist.
Machine learning engineer
Okay.
and big data analyst.
Big data. Okay. So I think. So again, these are interdisciplinary. So there's a lot of overlap. I think you just enter it in Google and it'll give you a lot of information. So I was also looking on Google the other day, and you will see these Venn diagrams which show what overlaps with what. But broadly speaking, machine learning is what is AI, the algorithms and machine learning. And data scientist is again, it looks at it's a subset of AI which looks at uh, a different aspect of data. They are all and big data is what Google used to do a few years back when it was starting off. When I was in school, there were no AI projects that Google had in its research labs. Search was their primary bread and butter for the company. And today, AI is a big deal in a company like Google. So these are all, I think these are all subsets of AI. So the use cases would be very similar, whether you're a data scientist, or machine learning, or big data.
Right. Can you share your experience of what you are working with in Accenture? Like, how has the experience been, and what all work have you done with Accenture and past companies?
I think I can't talk about the work other than because it's confidential. So
Okay.
and yeah, so unlike school, there are certain formalities which we have to adhere to in our office work environment. What is published is available. I have shared my website. I'll just type it in the chat window again. If you go to this website, you'll find my publications and any literature that I have shared. But beyond that, I mean, it's just like what you heard Andrew Ng talk about. I think that's what that's the day in the life of any employee today. And yeah, there are a lot of talks by Andrew Ng and Peter Novick that are available online. Both of them used to be with Google. I think Andrew Ng has moved to Baidu, which is the Chinese Google. Yeah, you'll find a lot of information if you go search on Google. Yeah, I think so. When we were in school, the internet, we were all excited for the internet. I mean, I used to log in on a dial-up connection when I went abroad and was applying. I used to send application emails to the admissions office, and I would get automated replies on a text interface. So that was something that would go on like a command prompt. I think it was links or something. I can't remember. So we come. We have. We are much advanced today. So there's. So yeah, I think just look on the internet and you'll find a lot of information.
Right. So next question is, How do you relate data science and data analysis to AI/ML? And are there other branches that are not so much recognized?
No, these are both similar. So I wouldn't. These are yeah, very similar.
Yeah. And there are what are some not much recognized branches in machine learning and deep learning?
Uh, I don't know. I think yeah, AI/ML is the umbrella uh, term for what artificial intelligence is. So uh,
Okay. The next question is, uh, do you recommend studying in India or abroad?
so I really don't have. I think if you have an opportunity and you that is something that you're interested in, then you should. My sister studied in RAIT. I went abroad for my studies, but really it's something that's a personal choice that you make, and uh,
I
yeah.
think the question is currently, I think, with regard to the situation which we have right now. So, in that scenario, what is suggested?
Oh, really? I don't have because I am not uh, 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 I don't forecast the weather as much as I forecast the pandemic. So I can't predict either of those. And the pandemic does have long-term repercussions in how businesses function as well as how education functions. So I know few folks who had gone for their studies are stuck there, or I think an education consultant would be able to give you a better information. I think if that's something that you have to do, then you have to do it. I think the pandemic, schools open the campus for education when the pandemic is over. So it's really it's not something. It's not a uh, one determines the outcome of the other. It's just a personal choice. If that is something. At the same time, you have to understand that if you invest a large amount of money and time in going through the admissions process. It is an effort. It is a significant effort that you will put in when you are going through an admissions process with all the standardized tests and the applications that you send out. So it is it is an investment in your personal time and your money. So I think you have to invest it wisely. At the same time, you will recuperate those expenses in no time. You would have you will on graduation you will be the cream of the crop, and you will recuperate those expenses. So again, these are trade-offs that are really beyond the scope of the discussion. I mean, I cannot comment on your personal circumstances. I would encourage you to get a college education, but it's really a personal choice at the end of the day.
Right. So the next question is, does a master from a foreign university provide a bigger career growth than the masters from a good Indian institute?
Here, this is something that I have an anecdote. I remember when the first industrial revolution happened with steam and the railroads. At that time, the railroads were a private industry. So if you take a case in America, each state in America would have a private company A that would build a railroad within the state. And if you go to another state, a company B would build another railroad there. And they wouldn't want to compete with each other. So what they would do is they would build rail tracks of different widths. So you would have a medium gauge railroad on one state, and you would have a wider gauge on another state. So when you couldn't if you were moving from one state to another, that train couldn't cross the tracks. So it's a step. That step of standardization is a cycle that happens in any industry. This was something that was there with the railroads century ago, and it usually these kind of economics, they are there for good reason, but over time you see a gradual standardization. So the same might happen for the education system. Again, I don't think any of the boards are better than the other. They have different value systems that they provide, but you never know. It's again, yeah. There's no uh, generalized rule over here that something A is better than the other. So until there is policies put in place, you cannot. You cannot forecast it. It's like the weather.
Right. So another question is, how big of an impact will quantum computing have in the development of AI in near future?
So I think this is. They say that there are quantum computers in the market today, but again, this is something that might take another 10, 20 years. So I think, I think the first step is to get into a computer science program and then vie for something in AI, ML. And I mean, computer science is a large field also. So I think if I had the presentation slides, the fields that I had shown, there are very qualified professors in each of those areas, and you will have again, you should not look at it as a competitive. The goal is not to have the largest bank balance. So I think there is, I think quantum is one field in computer science. So I think the way I see it, in an ideal world, I think everybody would like to be a computer scientist, and I'm not sure about the practical aspects of that, but I think first try and get into a computer science program.
Right. And there is this thing in like Indian colleges that whenever companies come for recruitment, you normally don't see ML engineer or something that kind of profile being offered to the students. So in case someone wants to apply to these positions externally, so what tips would you like to give to handle those interviews, and what prerequisites should be covered when we go for applying for such kind of jobs which normally don't happen through campus?
Yeah, I think your resume would have an objective stated on the resume, so you can clearly state your preference for the type of job that you're looking for. And when we go to campuses for recruiting, we clearly look at what the candidate has asked in the objective, and then he's considered for the available positions in the organization. So I think just make sure your resume concisely summarizes what you are interested in, what you are looking for, and that would be the best place to start. And other than that, if you're able to find a posting for what job you're looking for, then just go ahead and apply to that position. But I think it's important to convey on the resume, because that is what is presented to the employer. So
Right. And even the companies actually come with a designated profiles, right? So mostly the AI engineer and stuff are not easily seen in colleges being provided to the students. You normally get software engineer and those kind of roles, but AI engineer is something which you don't normally see being recruited from campus.
I think it varies. I remember we had gone to one of the campuses, and by the time we got there, I think Google and Microsoft had already completed their recruitment cycle. So we were like we had arrived there a week later. So I mean, you definitely have those kind of scenarios. There are frankly more than thousands or hundred thousands of companies, and there are lakhs of students, and everybody's trying to recruit students. So it's just because Shaun says to do something, it really, I think, depending on the company and the student, it's something that will happen. So I really cannot say. But at the same time, I think you have to. I can try to gauge your enthusiasm for a particular position in the company, but I cannot. Yeah, and I can try and do that on my part, and then guide you in any direction.
Right. So another question which has been asked is, did having a foreign education give you an edge in the job market?
So yeah, I think having it's important that you, if you're applying for education, to apply into a good school. You don't want to just go uh, to a school just because you want to get a stopgap uh, uh, degree of some kind. So important to see which school you're applying to, and all any of the top 10 schools always have a competitive edge. So I think Larry Page is an alumni of Michigan, as Ratan Tata is an alumni of Cornell. So there are advantages to being part of a school that has a large alumni base, and there are yeah, you that'll the just being a part of the culture on campus, or after you graduate in work, you will have a lot of interaction with your peers. So I think the edge comes from that aspect of the education system, that you meet a lot of your peers who you develop camaraderie with, whether it is in the school or in your work after you graduate. So and that's where you develop an edge in what it is you are doing.
Right. So another question is that if someone is starting their MS preparations like now, like if they're in the last year or something, so what tips would you like to give them for building their profile?
I think it's the same. I think it's whatever I've spoken so far. That would be it.
So that concludes the questions that have been asked by the audience. There is one more question. If you want to start a business, does having a degree make any difference?
Uh, so it's not. So there is no rule that goes if you want to start a business, you should have a degree. I think Bill Gates and Mark Zuckerberg, they had dropped out of school to start their businesses. So it really depends on the circumstances, and in my opinion, I think everybody should have a college degree, and it's not something that you can substitute with something else. So that is. I think everybody should be in school. I think Kerala has the highest literacy in the country, and I think that should be the case for the other states. Uh, and yeah, everybody should have a college degree.
So I think with that we conclude our doubt session. we would sincerely like to thank you, Mr. Shaun, for taking out time for this session and making it a success.
Thanks, Arghyadeep.
Yes.
It was
So-
nice to speak to all the students, and I saw there were quite a large audience.
Yeah. So I think with this we will conclude our Pi and AI session. We are looking for more Pi and AI session in the future as well. So I hope everybody enjoyed it, and I think we can finally call this meeting off. Okay. So bye everyone.
Thanks, everyone.